So let's do another example. Okay, let's just give you guys different examples you guys will see accordingly. All right, so for this one, so remember, we're going to solve for this, so we're going to subtract this over, and then we're going to divide by 2, and there we go. So now we got to figure out when is sine theta equal to negative 3 pi over 2. I mean, not 3 pi, negative radical 3 over 2. And again, right, that's just going to our unit circle. So I'll just give you guys quickly, right? So this ends up being 4 pi over 3 and 5 pi over 3 as well, right? So it works there. So our general solution, so remember, right, since it's just theta, there's no 2 into it, so it should be theta equals 4 pi over 3 plus the period of sine is 2 pi, and same process over here. Okay. And it works for 0, right, because obviously these work, but if you plug in 1, you're actually outside the range, which means those are the only 2 solutions we have here. Okay. So let's try another situation you guys will see as well. Okay. So notice I can get a little more elaborate based off these situations as well, right? So for example, let's say we have radical 3 cotangent theta plus 1 equals 0, and, bounded between the same portions as well. Okay. Right, so if we do this, we do the same process, solve for it. So radical 3 cotangent theta equals minus 1, divided over. So cotangent theta is equal to negative 1 radical 3. Now this one you actually have to work out to get, right? So remember, cotangent is x over y, right? Because it's the opposite. So we got to figure out what two values, when you divide them, give you negative 1 over radical 3. So I'll let you guys try to figure out, pop this up. So we got to just check S and check. So, it's x over y, so we got to divide this over that. So let me give you an example. For instance, let's suppose we want to figure out. So let's use the point 1/2 radical 3 over 2. Okay. And we want to see, is this a point that makes this? Well, if this is x and y, and we got to do it that way, so it'll be radical 3 over 2, okay, um, all being divided by 1/2, right? It's x over y. So if we use this process, it's going to be 1/2 times 2 over radical 3. Hey, look at that, it works. Cancel, cancel. We get positive 1 over radical 3. Okay, so we kind of got just of it, but we want the negative of it, right? So all we have to do is make one of them negative, and we got our answer. So our situation is going to be, well, not if they're both positive, but they are both opposite sign. So for instance, this one works, right? They're opposite sign there. So we know for sure 2 pi over 3 works. And the next time that opposite sign should be down here, which is right here, 5 pi over 3. And now that we have our answers, we can put it in general solution. So our general solutions for cotangent is going to be theta is equal to 2 pi over 3. And now plus, remember, the period of cotangent is pi k. And same thing at process over here, 5 pi over 3 plus pi k. And then we do the exact same process, right? We plug in 0 for k and 1 for k. And if you plug in 1 for k, you actually over your situation. So believe it or not, these are the only two as well that will show up. Okay. So let's just do a couple more. Okay. So next situation, let's suppose we have tangent evaluated at theta minus 1/2 plus 1. All right, so same process. When is tangent equal to 1? So we actually have to, go through those portions. So again, we're just looking when is tangent equal to 1. So give you a hint, right? That's pretty much when they're all both the same numbers. So when are they both the same numbers is at pi over 4. And where else? Well, these aren't because they're opposite sign. That gives you negative 1. We'll be positive 1. So the other one is right here, 5 pi over 4. Okay. All right, so we do that. So now we have this portion here. So let's see what's happening. So we have theta minus 1. So remember, the whole thing is equal. So this whole part is equal to now pi over 4 plus the period of it, which is pi times k. Right? And the same process on the other side. Theta minus pi over 2 is equal to 5 pi over 4 plus pi k. And now we solve for theta. So meaning we're going to add pi over 2 to both sides. So if we add pi over 2 to both sides, so basically adding it to this, right? So it's going to be pi over 4 plus pi over 2 plus pi k. We're just going to add it to this part, make it easier. And same process on the bottom. So it'll be 5 pi over 4 plus pi over 2 plus pi k, right? We're just adding this over and just simplifying both of these. So putting these together should give you, I believe, it's 3 pi over 4 plus pi k. And on the bottom, if you add these together, that's going to be 7 pi over 4 plus pi k. Okay. And now we do the exact same thing. So notice a little bit more work, but notice the same process, right? We set this whole thing equal to its individual ones and just, add or subtract this hand. We added pi. And now we get here and we do the exact same process, right? So we know for sure if k equals 0, it's going to be 3 pi over 4 and 7 pi over 4 as our answers. And we just, plug in 1, plug in 2. So give you guys a hint, if you plug in 1, it actually doesn't work. And these are actually our last solutions itself. Okay. Okay. Let's try a couple more. So the next one I want to talk about is a fun one. And you actually will be seeing like, huh, when you guys see these type of questions. So let me show you what I mean by huh. Hopefully you're looking at what in the world am I doing here? And believe it or not, it's actually not that bad. Okay. So for instance, let's suppose I did it this way instead. And ask you solve for that instead. And I'm pretty sure you guys say, okay, that's easy, right? We just use the AC method and so forth down the line, right? So AC method, 2 times 3 is 6, minus 5. So two numbers when you multiply is negative 3, negative 2. So your factors are going to be x minus 1 and 2x minus 3 equals 0, right? And we just solve for x. Well, what if I told you that's exactly what you have to do here? Literally identically the same. All we're doing is we're going to set x equal to sine theta. It's the same process. Why don't we just finish this up? So we have x equaling 1 and x equaling 3 over 2. And now we just rewrite x's, right? So now we have sine of theta equals 1 and sine of theta is equal to 3 over 2. And now we just, again, going back to unit circle, figure out which ones go where. Now, it's no way impossible to figure out what sine theta of this portion. We're just going to cross that out because we have no idea what that is. But we do know what sine 1 is, right? That's going to equal pi over 2. Okay, so there's our answer. So we know our general solution is going to be pi over 2 plus 2 pi k. So it works when k equals 0. And if k equals 1, we get that, which gives you, I believe, 5 pi over 2, which is well above 2, so we actually only get one answer. But what the whole thing about this question is, I don't want you guys to be scared when you see this. It's exactly what you've already seen before in quadratic form. So you just, if it's easier, just rewrite it. Okay, I'm going to let x equal whatever that is, rewrite them, and just solve for it. It makes it far easier. And at the very end, backtrack until you get your final answer itself. Okay? So let's just try another example so you can see how this will work out. Kind of like this. Okay. So let's suppose we have 2 cosine squared theta plus cosine theta is equal to 0. Okay. Well, if it's easier, why don't we just say we're going to let x equals cosine theta, just for fun. So now this becomes 2x squared plus x equals 0. And I'm asking, solve for x. So hopefully now this is much easier to look at, right? So we would factor x out. So if I take out an x, that gives us that. So therefore we have x equaling 0, and then 2x plus 1 equals 0. So we have x equals 0 and x equals negative 1 half. And now we backtrack. So therefore we know that cosine theta must equal 0, and cosine theta must equal negative 1 half. Well, when is cosine equal to 0? Well, going backtrack to our unit circle, right? Cosine is equal to 0 at pi over 2 and 3 pi over 2. So we know for sure it's pi over 2 and 3 pi over 2. Okay, and now we go over here, back over here, and when is cosine equal to? Negative 1. So cosine is equal to negative 1 in 3 and 4. I mean, sorry, quadrant 2 and 3. So right here, which is 2 pi over 3. And where else? Right there, 4 pi over 3. Okay, so this means we have 4 initial thetas, right? But I'll give you a hint. These are the only 4 that work within between our interval. I forgot to write interval between 0 and 2 pi itself. Okay? So, there's going to be a lot of different ways things are going to be given to you, but all I want you guys to do is slowly break it down, right? Just use your template when it comes to, and it's actually not as bad as you may think.